In this video, we are going to determine whether the function has a critical point at a specific point x or no. So for that reason, you must know that any derivative, if the derivative of any function is equal to 0, then we must have the critical number at that certain value of x. Which means that before doing anything, you have to take the derivative of the given function. And for that reason, apply the appropriate method of derivative, and here apply the chain rule along with the power rule. It means bring the two in the shoulder and then write the inner function as it is, and one time take the derivative of the inner function. Since you have to check at x equals to 4, there is a critical point. So wherever you have the x, you have to replace x by 4. After doing that, you have to read the table accordingly. So for example, here too. Now f of 4, this is the function f of x. Here all the values of x are given. So f of 4. So you will go to the f, and where is the x? X is here and f of 4 is here, means 2. So you will write here 2. Then f prime of 4. So this is f prime. This one is f prime, second one, and here is the 4, and the f prime of 4 equals to 0. So anything multiplied by 0 gives you 0, which shows that yes, there is a critical number at x equals to 4. Now they are asking you whether at that point whether you have a local maximum or local minimum at that point, or neither. So what you have to do, you know that the local maximum or minimum in these cases can be determined by taking the second derivative. So take the second derivative of the given function. You have 2f of x. Now there are two functions over here, right? 2f of x and f prime x. So better to use the product rule, according to which fg prime plus gf prime. It means the first function, derivative of second function, plus second function, and the derivative of the first function. So uf, it means 2f of x as it is. G prime, it means f double prime of x, plus g, it means f of prime of x as it is, and derivative of the first function, which will gives you 2f prime of x. After doing this, just substitute again one more time to check. Substitute the value of x just to check that do you have the local minimum or maximum. So 2f of 4, f double prime of 4 plus f prime of 4 plus times 2 f prime of 4. Now again check the table. So 2 as it is, f of 4. So here this is the f and this is the 4. So the value of f of 4 is 2. F double prime of 4. So here is the f double prime and 4. So this value is negative 3 plus f prime of 4. So f prime of 4 is 0 times 2, and then again f prime of 4 is 0. So you will get 3 times 2 6, 6 times 2 12, negative 12 plus 0. So negative 2, you know that is less than 0. So if the second derivative is less than 0, you know that it has a concave down, and concave down represents the relative maximum. So it means according to the question, you have the relative maximum. Check the second question. In this question, they are asking you to determine the points, the critical points at x equals to 0, x equals to 2. So take the derivative of the function. Now this is f of x square. It means inner function has a power, not the outer function has the power. So first of all, take the derivative of outer function, which is f, so f prime of x square. Then take the derivative of inner function, that would be 2x. Now you have to read at x equals to 2 the critical function, the critical number. So replace x equals to 2 everywhere. So f prime of 2 square times 2 times 2. So you will get f prime of 4 times 2 times 2 gives you 4. So I'm writing it here, 4. Now here you will have f. Now f prime of 4 here is equals to what? Equals to 0. So everything, so b prime of 2 equals to 0, which says that there is a critical number at x equals to 2. After that, what you will do? You have to find whether you have a relative minimum or maximum. Take the second derivative of this function. So again, you have two functions, that is f prime of x square and 2x. So write the first function as it is. Take the derivative of second function plus write the second function as it is and take the derivative of second function. So derivative of second function is f double prime x square and then 2x. Now replace x by 2. So f prime of x square times 2 plus 2 times 2, f double prime of 2 square and then again 2 times 2. Solve it. So f prime of 4 times 2, it gives you 2 here, plus 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, f double prime of 4. Now replace f prime of 4, f prime of 4 is 0 plus 16 and f double prime of 4 is equals to negative 3. So your answer is negative 48, which is less than 0. So you have a relative or local maximum. So there is another question according to which you have to calculate whether you have a critical number at x equals to 3 or not. So for that reason, take the derivative. Now here f of x. So this f is the outer function and this f of x is your inner function. So for that reason, apply the chain rule, take the derivative of outer function, then write one time the inner function as it is, and then take the derivative of inner function, that is f prime of x. Now put x equals to 3 everywhere, f prime of f of 3 and f prime of 3. Now check with the help of the table. So here f prime and this f of 3, check here, f of 3 is equals to 1 and then f prime of 3, so here f prime of 3 is negative 2. Okay, now f prime of 1 is what? F prime of 1 is 0. So 0 times negative 2 gives you 0. So yes, you have a critical number at x equals to 3. Now take the second derivative of the function. So again you have to apply the product rule, the first function and the second function. So write the first function, write the first function, so f prime f of x as it is. Take the derivative of the second function, which will gives you f double dash of x. Write the second function as it is and take the derivative of second function. So second function will be f double prime, outer function. Write the inner function as it is and then take the derivative of inner function. Replace all the x by 3. So you will get f prime of f of 3, then f double prime of 3 plus f prime of 3, f double prime of f of 3, and be careful because one mistake will make your whole question completely wrong. So f prime of f of 3 is what? Now check, f of 3 is 1. F double prime of 3 is 0. So this whole thing becomes 0 plus f prime of 3. So f prime of 3 is negative 2. Then f of 3 is 1. And f prime of 3 is again negative 2. So you will get positive 4, which is greater than 0. So you have relative minimum. Now, just check if that no one is making the mistake. That is the basic thing. So here is another question. So dx equals to f of 4x minus 2. Take the derivative of the function. You will take the derivative of outer function, that is f prime of 4x minus 2, and then take the derivative of inner function, which is equals to 4. Now substitute x equals to 1, so d prime of 1 equals to f prime 4 times 1 minus 2 times 4. So you can write the 4 in the beginning, and f prime of 4, that is 2. So 4 f prime of 2, now check, that is equals to 0. So yes, you have a critical number at x equals to 1. Now what does it is? Is it the relative minimum or maximum? So for that reason, of course, you have to take the second derivative. Now here you have 4. Second derivative is 4 f prime of 4x minus 2. So write the 4 as it is, constant multiple rule, and take the derivative of the second function, that will be f double prime 4x minus 2, and now the inner function is 4. So 4 times 4 16, f double prime of 4x minus 2. Now replace x equals to 1. So we will get 16 f double prime of 4 times 1 minus 2 will gives us 2, and f double prime of 2. So here f double prime of 2 is equals to 0, which gives you 16 times 0 is 0. It means the second derivative test fails. Second derivative test fails. It means that we have neither local minimum nor local maximum. So you will write here neither, because the second derivatives fail. It is equals to 0. It doesn't have the concave up or concave down. So the last question in front of you. So the main art is to take the derivative and understand that which rule they are applying. So f of x plus 3. So it's very clear that there is a function and there is a function inside this function. So of course you will apply the chain rule. Outer function is f, so f changes into f prime. We write the inner function as it is, then take the derivative of inner function, that will gives you 1. So you will get f prime of x plus 3. Now check whether you have the critical number at x equals to 0 or no by replacing 0 as x. So f prime of 3. So f prime of 3, so f prime of 3 is negative 2. So of course you can say f prime of 3 is negative 2. It means it doesn't possess the critical number. It doesn't possess critical number. There is no critical number. There is no critical number at x equals to 0. So no need to perform more tests because there is no critical number. So I hope that these, how to express, how to take the derivatives, how to express the derivatives or second derivatives with the help of the table, you understood. And if there are the questions, just let me know please.